We've already seen a cycloid. In this video, we are going to investigate what happens around this region. So let me just illustrate this cycloid. Hang on. So this is a cycloid here. We're keeping track of one particular point on a circle, and we've seen this before. So in this video, we're going to investigate what happens around this region here. So in this video, we are going to investigate what happens around this region here, because as it's moving about around this region, if you keep on zooming into this bit here, is it actually doing this? Because the circle is always moving to the right. It's always moving to the right. But if you look at this region here, is it actually doing this? If you keep on zooming into this bit, will it actually be doing this, or will it be doing this, where you have some sort of angle in between here? This where you have some sort of angle in between here, an angle theta, say. Or is it actually doing this, where it's vertical, near enough vertical? Or is it actually doing this, where it goes back on itself around this region? From this, we can't really tell from this. So we're going to investigate which of the four scenarios it will adopt. Okay, so hang on. Let's begin by doing this. Hang on. So for let's analyze it in terms of vectors. So we are trying to work out the position vector. So as the circle rotates, we are trying to work out this position vector. Suppose the circle is over. Suppose the circle is over here. We are trying to work out the position vector from the origin to here. So we are trying to work out the position vector. So to get the position vector, well, let's to get the vector from the origin to P, we are going to do this. We are going to move along here, which would be this thing here, and then we are going to go straight up. That will then be this thing here. And by the way, we've already done this many times. The distance from here to here is actually given by this thing here. So if you don't understand this bit here, track back to one of the early videos on a cycloid. We've done this many times. After time t, this distance here is actually at. Well, anyway, to find our position vector from the origin to P, we would move along here, which would be this vector here, and then we would go straight up, which would be this vector here, and then we would move this to move from B to P is given by this thing here, because hang on, if you form a right angle triangle here, this angle here is T. So hang on, and we know the radius is A. The radius is A. So this would be sine. So it would be sine t equals well, we're trying to work out the x direction, equals x over the radius, which would be this. So times both sides by A. So that will then give you this. So in the x direction, you would go backwards. Remember, positive would be this way, negative would be to the right. That's why you've got negative. That's why you've got negative A sine t. And then don't forget to travel from B to P. To travel from B to P, you would have to go down. You would have to go down from the center of the circle. So you have to go down slightly. So to go down slightly, it would be this. From your right angle triangle, you are trying to find this y here, because you've got to go from the center of the circle downwards here. So this, remember, the angle is t, the radius is a, so this would be cos. So it would be cos t equals adjacent over hypotenuse, and then you times both sides by a. That will then give you this. So in the y direction, it would be this thing here. Don't forget, you're going down, so it's got to be a negative. Well, to travel from B to P is given by this. So if you want this vector here from the origin to P, you would have to move all along here, up here, and then in this direction here. So that will then take you to here. So if you sum up these three vectors, it will give you this thing here, OP. Okay, so it will be this in the x direction. It will be this plus this plus this. That will then give you this. And then looking at it in the y direction, it would be you adding this plus this plus this. That will then give you this. Well, to travel from 0 to p is given by this. Well, 0 to p is really your position vector. So you can just rewrite this thing here as this. So your position vector is given by this. So we are trying to find out what happens around this region here. So let's simplify our scenario. Rather than looking at a circle of radius A, let's look at a circle of radius of 1, So let's consider a unit circle where the radius is 1. So this thing here will be 1, and then this thing here will be 1, and so on. So our position vector, this whole thing here, will be given by this, because we are looking at a unit circle. Okay, well, once you've got your position vector here, you can rewrite it as this. So in the x direction, it will be given by this. In the y direction, it will be given by this. So I will continue in the next video where we have to look at Taylor approximation to understand what's really happening around this region here. So we are currently at this stage here, and I will continue from here. Okay.